Now that both current and voltage have been discussed, we can introduce the concept of signal and noise. Current and voltage are not fixed quantities. They can and usually change with the time inside the circuit. Here you can see the definition of electrical signal. An electrical signal is an electrical quantity, such as current, voltage, or electromagnetic wave, that can be varied in such a way as to convey information. On the right, you can see two examples of electrical signals. This image is a capture from an oscilloscope. An oscilloscope is an instrument that can be used to see how the voltage varies across time. In this image, the voltage at two nodes of a circuit have been captured. This will be one node and this will be the other node. Now we don't know exactly what's happening here, but as you can see, the voltage is going up and down in a way that sounds somewhat predictable, and it definitely looks like a behavior that is intended for a circuit. So this is what we call electrical signal. Conversely, noise is an electric disturbance in a circuit that interferes with or prevents with the reception of a signal or of an information. You can think of it as the buzz on a telephone or snow on a television screen, like shown here. This graph here shows how the voltage looks like when it's carrying just noise and no signal. As you can see, the voltage here is just going up and down in a random fashion and not carrying any information. It is important to make sure that the signal is always much bigger than the noise. Let's now look at some notable type of signals. This will allow me to introduce some terminology that I will use in future lessons. I will discuss voltage signals for simplicity, but similar consideration apply to the current as well. The first type of signal is the constant signal. This is a signal that has always the same value at any time. This voltage is also called DC voltage. So this is called constant, but also DC. The second type of signal is the pulse. A pulse is a signal that starts at a certain level, it goes briefly to another level, and then it goes back to the original level. The pulse can go up, can go down, and the two levels are arbitrary. So this signal is called pulse. Other notable signals are the step and the spike signal. This is a step, and this is a spike. A step is just part of a pulse, just the edge that goes up or that goes down, that is the step. And you can think of the spike as a very, very short pulse. Finally, this signal is called ramp because the voltage increases or decreases at a steady pace.